Hello, it is time for our SHS 3 Core Mathematics program. This is brought to you by Senlos. I am Ben. In our previous lesson, we learned about volume of prisms and how to solve problems involving volume of prisms. In this lesson, we shall learn how to find the surface area of a cone. By the end of this lesson, you will be able to calculate the surface area of a given cone. Let's look at a right circular cone. A right circular cone is a three-dimensional figure with circular base and a curved surface. This is an example of a cone. The vertex of a cone is the topmost tip of the cone. The height of the cone is the vertical or the perpendicular distance from the vertex to the base. The slant height of the cone is the shortest distance on the curved surface between the vertex and the point on the circumference of the base. So you see in the diagram, we have the vertex at the top, there is the vertical height, we have the slant height and the circular base. Now let's look at the net of a right circular cone. The net of a right circular cone is made up of curved surface and the circular base. In other words, the net of a cone is the same as the plane used in developing the cone as shown in your diagram. We have a circular base and a sector. The sector is used to form the curved surface, and the arc length becomes the circular base of the cone. From the diagram, we have L, which is the slant height of the cone. We have 2 pi r, which is the circumference of the circular base, and r is the radius of the circular base. We now look at how a right circular cone is formed. A right circular cone is formed from a sector. Let us consider a sector and see how a cone can be formed out of it. You see a sector, we have the radius and the circumference of the sector. In the diagram, the sector AOB, where OA and OB represent the radius of the sector. AB is the arc length of the sector. When the sector is folded and OA coincide with OB, a cone is formed. From the cone in the diagram, point A and B coincide at point C. OC becomes the slant height L of the cone. Originally, OC is the radius of the sector AOB. Now, a circle is formed at the base with a new radius, R. This R is small r. Now, let's look at the surface area of a cone. From diagram A, the length of the sector AOB is given by theta over 360 times 2 pi r. We know this from our SHS 2 core maths. Again, since the arc length of sector AOB has become the circular base of the cone in diagram B, it implies that the arc length is equal to the circumference of the circular base of the cone. We also know that the circumference of a circular base is given by 2 pi r. Since the equation of the arc length AB is equal to the circumference of the circular base, it means equation 1 is equal to equation 2. Substituting, we have theta divided by 360 multiplied by 2 pi big R equals 2 pi small r. If you simplify this expression, then you have theta divided by 360 multiplied by big R and is equal to small r. This is because the 2 pi will cancel the 2 pi. Simplifying further, we will have theta divided by 360 to be equal to small r divided by big R. Let's call this equation 3. Now the area of the sector AOB is given by A equals theta over 360 times pi r squared. Let's call this equation 4. From equation 3, we know theta over 360 is equal to small r divided by big R. So we want to substitute this into equation 4, and that will give us A equals small r divided by big R multiplied by pi big R squared. Simplifying, we have A equals pi small r times big R. But R is the same as the slant length, L. Therefore, big R is equal to L. So if you substitute, then we have A equals pi r L. The R now is small r. Hence, the curved surface area is given by A equals pi r L, or A equals theta over 360 times pi L squared. The area of the circular base is given by A equals pi r squared. Therefore, the total surface area of a cone is given by, that's total surface area equals pi r squared plus pi r L. This time we are talking about small r. Or we can have the total surface area to be equal to pi r squared plus theta divided by 360 multiplied by pi L squared. Let's now look at a semi-vertical angle of a right circular cone. From the diagram, ABC is a right angled triangle. So we can apply the Pythagoras theorem to find any of the sides of triangle ABC. L is the slant height, R is the base radius, H is the vertical height, and theta is the semi-vertical angle. So applying the Pythagoras theorem, we have L squared equals H squared plus R squared. Now considering triangle ABC, we can apply any of the trigonometric ratios to find the semi-vertical angle theta. I hope you remember our trig ratios. We have sine, cosine, and tangent. Now from triangle ABC, we have theta as an angle, and we have the size of the triangle to be R, H, and L. So fortunately, we have all the sides of the triangle. So in finding theta, one, we can use sine theta, which is R divided by L. We can also use cos theta, which is H over L. And we can use tan theta, which is R over H. We then find the inverse of the trig function to get angle theta. Shall we take a few examples to illustrate what we have so far discussed? A sector of angle 150 degrees is removed from a thin metal sheet of radius 60 centimeters. It is then folded with the straight edges coinciding to form a right circular cone. Assume pi to be 3.142. Calculate I, the radius of the base, II, the curved surface area, III, the total surface area of the cone, to 2 decimal places. The first thing in the solution is to try and draw the diagram. Now, diagram A represents the sector folded into a cone with base radius R in diagram B. Now we are to find the relationship between the base radius and the radius of the sector R. 1. The relationship between the base radius small r and the radius of the sector big R is given by small r equals theta divided by 360 multiplied by big R. From the question, big R is equal to 60 centimeters and theta is equal to 150 degrees. If you do the appropriate substitution, then we have R equals 150 degrees divided by 360 degrees times 60. Therefore, our R is equal to 25 centimeters. Let's look at II, where we are to find the curved surface area. We know the curved surface area is given by A equals pi RL, where L is the slant height, which is the same as big R. Now, picking our values and making the appropriate substitutions, we have A equals 3.142 multiplied by 25 multiplied by 60. Using our calculators, we have A equals 4,713 centimeters squared. The next question is to find the total surface area, which is given by the curved surface area plus the circular base. So you have our total surface area equals pi RL plus pi R squared. Making the appropriate substitutions, we have total surface area equals 3.142 multiplied by 25 multiplied by 60 plus 3.142 multiplied by 25 squared. Simplifying, you have 4713 plus 1963.75, which gives us a total surface area of 6,676.75 centimeters squared. That's very easy. Let's look at another example. A sector of radius 14 centimeters subtending an angle of 240 degrees at the center of the circle is used to form a cone. Assume pi to be 3.142. Calculate I, the base radius of the cone. II, the perpendicular height of the cone. III, the semi-vertical angle of the cone. IV, the curved surface area of the cone. V, the total surface area of the cone. That's a lot of questions, but we'll take them bit by bit. Shall we go through the solution? The first step is to draw the sector and the cone. So we see our sector and the cone. They are all not drawn to scale. Diagram A represents the sector folded into a cone with base radius R in diagram B. The relationship between the base radius R and the radius of the sector R, big R this time, is given by small r equals theta divided by 360 degrees multiplied by big R. Now, from our question, our big R is equal to 14 centimeters and our theta is equal to 240 degrees. If we make the appropriate substitutions, then our small r is equal to 240 degrees divided by 360 degrees multiplied by 14. And that will simplify to r equals 9.33 centimeters. Let's look at the second question. Now, considering the right angled triangle ABC in the cone, we will apply the Pythagoras theorem to find the perpendicular height h. From the Pythagoras theorem, h squared plus small r squared is equal to big R squared. But our r, as calculated from the previous question, is 9.33 centimeters. And our r big R is equal to our L, and that is 14 centimeters. If you do the necessary substitutions, then we have h squared plus 9.33 squared equals 14 squared. And that will simplify to h squared plus 87.0489 to be equal to 196. If you simplify, you have h equals the square root of 196 minus 87.0489. And that will give us h equals 10.44 centimeters. Therefore, the perpendicular height of the cone is 10.44 centimeters. That's good. Now the third question. Let's consider the triangle again. ABC. You see our dimensions. We are to find theta, which is the vertical angle. From trigonometry, we can use tan theta equals r over h, because we know our small r and we know our h. So if you do the necessary substitutions, then we have our theta to be equal to tan inverse of 9.33 divided by 10.44. And from our calculators, you get theta to be equal to 41.79 degrees. Therefore, the semi-vertical angle of the cone, theta, is equal to 41.79 degrees. That is easy. Let's look at the fourth one. We are to calculate the curved surface area. And from our formula, the curved surface area is pi RL. Small r this time. If we do our substitutions, because we have all our figures, then our curved surface area is equal to 3.142 multiplied by 9.33 multiplied by 14. And that will give us 408.408 centimeters squared. Now let's look at the fifth one, where we are to calculate the total surface area. We know our formulas. Make sure you can remember the formula. The total surface area of a cone is given by pi RL plus pi r squared. That's the curved surface area plus the base area. We have all our parameters, so you only have to substitute after you have quoted your formula. So if you substitute, we have 3.142 multiplied by 9.33 multiplied by 14 plus 3.142 multiplied by 9.33 squared. And that will simplify to 410.408 plus 273.508. If you put them together, then we have 683.916 centimeters squared. That was very, very easy. Let's take another example. Find the area of the curved surface of the cone generated by a sector of a circle of radius 12 centimeters and arc length 25 centimeters. Again, our pi is equal to 3.142. Let's look at the solution. We draw a sector and then the cone. The radius of the sector is 12 centimeters, and that becomes the slant height of the cone. The arc length is equal to the circumference of the base of the cone. That is L equals 2 pi r, where L is the arc length and r is the base radius of the cone. But from the question, we were given L equals 25 centimeters. So if you do our substitution, we will have r equals L over 2 pi. And that will give us R equals 25 divided by 2 times 3.142, which will simplify to R equals 3.978 centimeters. Now we can find the curved surface area using our formula pi r L. We know L is 12 centimeters, which is the slant height. Therefore, our curved surface area is equal to 3.142 multiplied by 3.978 multiplied by 12. And that will give us 149.987 centimeters squared. That's great. We continue to take more examples to make the topic a little and more clearer. So let's take another example. A sector of a circle of radius 7 centimeters subtending an angle of 270 degrees at the center of the circle is used to form a cone. A. Find the base radius of the cone. B. Calculate the area of the base of the cone to the nearest centimeter. This time, let's take our pi to be 22 divided by 7. Let's look at the solution. As usual, we illustrate the sector and the cone in a diagram. So we have our sector and our cone. We already know the relation between the base radius small r and the radius of the sector big R, as small r equals theta divided by 360 times big R. But from the question, we have big R equals 7 centimeters and theta equals 270 degrees. So making the appropriate substitutions, we have small r equals 270 degrees divided by 360 degrees multiplied by 7. And that will simplify to 5.25 centimeters. So the radius of the base is 5.25 centimeters. Now the next question is to find the base area of the cone. And the base area of the cone is a circle, and that is pi r squared. So we do our usual substitutions, and we have A equals 22 divided by 7 multiplied by 5.25 squared, which is our radius calculated. Therefore, the area of the base is equal to 86.625 centimeters squared. I think another example will not be bad. The slant height and the diameter of a conical tomb are 18 meters and 32 meters respectively. Find the cost of painting its curved surface at a rate of 50 cedis per 100 meter squared. Now the solution. As usual, you need to draw the diagram. Always try and draw your diagrams before you start. Our diagram is shown with a base diameter of 32 meters and a slant height of 18 meters. We find the curved surface area, which is pi r L. Now, our diameter was given as 32, so we need to calculate our radius, which is half of the diameter. So in this case, our radius will be 32 divided by 2, and that is 16 meters. We then substitute this into the curved surface area formula, and that gives us 22 divided by 7 multiplied by 16 multiplied by 18. And that will give us 905.14 meter squared. Now you can find the cost for painting the curved surface area. You are told that the cost of painting 100 meters squared is 50 cedis. Therefore, the cost of painting 905.14 meters squared, if you do our simple proportion, That would be 905.14 divided by 100 multiplied by 50 cedis. And when we simplify, we are going to get 452 cedis. Hence, the cost of painting the curved surface area is 452 cedis. That was great. In this lesson, we have learned how to calculate the surface area of a cone. Again, we have also studied the following points about the cone. 1. How to draw the net of a cone. 2. The relationship between the radius of the base and the slant length. We have also looked at how to label the various parts of the cone, and then how to find the semi-vertical angle. This brings us to the end of our discussions on surface area of cone. In our next lesson, we shall learn about the volume of a cone. I hope you have learned a lot, and you keep practicing a lot more questions on all that we have been discussing on this program. Join us again for the next lesson. Goodbye.